Okay, so we're going to learn how to integrate sine square x and cos square x, and these are not on the formula sheet, so you need to know how to do them. How do I integrate sine square x, cos square x? So what you need to do is, now if you try to do this, let's say we try to do that here. Now definitely it doesn't become sine cube x, isn't it? Because if I differentiate sine cube x over 3, it doesn't give me sine square x, isn't it? Because if I differentiate it, you get 3 sine square x over 3, but if you differentiate sine, you get cos x. So it's actually equal to this. So it doesn't become sine square x. So we need to use another method to do that. So what do? We can actually change the square sine square x into a without the square by using a double angle formula. Okay, so to do this, we're going to do the first formula. Recalling the formula for cos 2 theta is equal to 2 cos square theta minus 1. We're going to make cos square theta the subject. So what we do is add 1 to both sides, plus 1 equal to 2 cos square theta. So see that negative 1, I moved it to the left side. So you write cos 2 theta plus 1 equal to 2 cos square theta. And then I could divide both sides by 2. Yeah, thank you. And then the 2 get cancelled. You end up getting cos square theta equal to cos 2 theta plus 1 over 2. Actually, I prefer to write it this way. You will see later on why I do it this way. I'll write the 1 first. You will see the reason why later on. Okay, so I could convert a square of something into cos of a double angle. That will help us to integrate, because we can integrate cos of any angle, but we cannot integrate with a power. We can differentiate with power, but integrating with a power will be difficult, so we have to convert that to a double angle. And I want you to do the same thing for the other formula, so that you can express sine square theta in terms of cos 2 theta. Do that as well. So you get these two formulas. Okay, so we'll do the other one. So we're going to move this sine square theta to the other side. So you get 2 sine square theta plus cos 2 theta equal to 1. I want to keep things positive. Then subtract both sides by cos 2 theta, which will cancel these two. So you get 2 sine square theta equals to 1 minus cos 2 theta. And like before, we divide by 2, we get a formula for sine square theta in terms of the double angle formula. Hopefully now you see why I write the 1 first, because the sine square theta looks same as the cos square theta formula, except the other one has a minus instead of plus. So they look very similar, isn't it? If I write the 1 first, they look the same, except the cos square is the plus, the sine square is the minus. Okay, that will help you to remember the formula. So if you can remember these, that will help you. So instead of deriving each time, just remember them. But if you still have difficulty remember them, you can just derive in the test, but it will just take you extra time to do that. So I recommend you to memorize these 2 extra formula, which I'm going to highlight. Unfortunately, they are not on the formula sheet, so you need to memorize them. Okay, good. So we got these 2 formulas. Now, I also want to say something about this formula. Now, what's cos square theta plus sine square theta equal to? 1. Now, you can see that it adds up to 1 with these 2 formula, isn't it? So if I add them together, cos square is 1 plus cos 2 sine theta over 2. The other one's 1 minus cos 2 theta over 2. And what happened to the cos 2 theta? They cancel. So that's how you can help you to remember them. They must cancel each other out. So you know, 1 must be a plus, 1 must be a minus. You get half plus half, which is 1, as expected. As expected. All right, good. All right, so we're going to use these formulas to help us to do these 2 typical HSC questions that's been asked more than a decade ago. Alright, so let's do them. So what do we do? Alright, we're going to do these questions. So one is asked in that particular year, 2001 and then 2002. Let's do them. Alright, so what we do is this. First, this is cos square. I write down the formula for cos square theta, which is equal to 1 plus cos 2 theta over 2. Now this theta can subject to change. So I could change the theta, in this case is 3x, into 3x here, into 3x there. So that means using the formula, you can write cos squared 3x equal to 1 plus cos double the 3x. Double the 3x. And then you get 1 plus cos 6x over 2. So instead of integrating cos squared 3x, I could integrate 1 plus cos 6x. And that can be done using the formula on the reference sheet. So let's do that. So you write 0 to pi 1 plus cos 6x over 2 dx. And you just work out. So take the half out. So you write half integral 0 to pi 1 plus cos 6x dx, and just integrate each term. Half again, x plus 1 on 6 sine 6, oh, not 1 on 6, not 1 and a half, 1 on 6, 1 over 6 sine 6x, pi and 0. And then we substitute. Half, you get pi plus 1 over 6 sine 6 pi. And the other bit, you get 0 plus 1 over 6 sine 0. So what you do is, if you know your exact value, that will be quick. If not, just use your calculator. I think sine 0 is 0. In radian mode, check that there's an R on the top. 0. Sine 0 is 0. Sine 6 pi is also 0. You get 0. Okay, everything's 0, so that's 0. That's 0. That's 0. So you end up with half pi as your final answer. Okay, try the next one. It's the same procedure. Right? Use the same procedure for the next one. I'll just enlarge this so you can see the full page. That's the procedure. Start with the formula. Convert the sine square 4x in terms of cos. And then integrate. And then substitute if it's a definite integral. Go. Go through. So write sine square theta equal to 1 minus cos 2 theta on 2, which is 1 minus sine square 4 theta x equal to 1 minus cos 8x over 2. And then you integrate that, so you get 2, 0, pi on 4, 1 minus cos 8x on 2. The lucky thing is that the 2 get cancelled. And then you just integrate term by term. So you get equal to x minus 1 over 8 sine 8x. Substitute pi over 4 and 0. Substitute pi on 4, you get pi on 4 minus 1 on 8 sine 8 pi on 4 minus 0 minus 1 over 8 sine 0. And then 8 pi over 4, the 8 and 4 get cancelled, you end up getting 2 pi. And then you get pi on 4 minus 1 over 8 sine 2 pi. Right, what's sine 2 pi? You get 0, which is equal to pi over 4. Okay, so let's write a note there. It seems that a lot of questions involve pi because when you double things, you ends up getting pi. So let me write down a note that if I do sine of any pi, actually I'll just write this, sine pi equal to sine 2 pi equal to sine 3 pi, etc. They're all equal to 0. Just remember, whenever it's a multiple pi, sine is 0. That will help you. Okay, hopefully it's all done. We're going to move on to the next page to do more integration. Okay, all done. So we're going to move on to the next page. Next page, good. All right, Pythagorean identity. So that will help us to integrate the square of all 6 trigonometric ratios. We've already seen how to do the first one. We can also use these 2 formulas to do the other one. Let's do this one very quickly. So just remember sine x squared, sine square x is 1 minus cos 2x on 2 dx. And then you can write it as half minus half cos 2x dx. And if we integrate that, will be half x minus 1 over 4 sine 2x plus c. And do the same thing for the other one. Okay. After you do this, do the cos square one as well. You get integral 1 plus cos 2x over 2 dx. Split into 2. And then you get 1 on half x minus plus 1 on 4 sine 2x. These formulas are not to be memorized because it doesn't work for other angles. So you should do this. You should always do the conversion every time. So always have to convert rather than trying to remember the formula because it's different each time. Okay, so basically these 2 are actually extension 1 level. So this is extension 1. You only see them in extension 1 exam, not tuner exam. Okay, but the other 2, you will see them in tuner exam because that can be done at tuner level. Right, all done. Okay, after we do this, now how about sec square x? What's the primitive of sec square x? Anyone remember? It's tan x. So sec square x is easy. But tan square x is different. How do I integrate tan square x? That's not on the reference sheet. How about we change tan square x into sec square x? That's why we use this formula. So tan square x is sec square x minus 1. Sec square x minus 1. So I could write that in terms of sec square x, which means I could integrate it. So therefore, integral of tan sec square x is tan x minus x plus c. So that can be asked in a tuner exam like the tan square. Just change that to a sec square x minus 1. And then we've got the last 2. We'll just go through it. Yeah. No, I think they could. Yeah, possibly. Alright, the last 2, you can also do it. So you can change cosec square x equal to sec square on 2 minus x. Which means that I could use the formula above, except there's a minus x. That's okay. You just have to do equal to the negative of tan pi on 2 minus x plus c. Get the idea? So that minus is used, which transfer here, right? And then tan of pi minus pi on 2 minus x become cot. So the formula become negative cot x. So when you integrate the cosec square x, you become negative cot x. Yep. Yeah, it's like using this formula. Remember the formula cos 90 minus x equal to sine x. And this is cosec 90 minus x equal to sec x. Yep. So some of these are useful in this context. Actually, I should write that at the bottom. Let me just highlight this and put it over here. Right. Alright, good. It fits nicely up underneath. Alright, after we do this, we can do the cos square one. And the method to use is exactly the same as above. So we change cos square into cosec square x minus 1 using the formula we see above, using this formula, this one here. And after that, we can now integrate cosec square, because the integral of cosec square is, we just got that, negative cot, isn't it? Negative cot x, integrate negative 1 is negative x plus c. Right, it's all done. All 6 trigonometric ratios with the square are now known. Note the techniques used to derive them. Alright, good. And then we'll do the integral of the other bit. And then after that, we'll look at some other questions and then some HSC questions, then we're done. Alright. Okay, good. Alright, next one, next page. Alright, you still copying? Okay, I'll just leave it there for a minute. Okay, good. Let's move on. Hopefully you'll finish. Alright, integration of other trigonometric functions. Let's start with sine. Sine is negative cos. What's cos? Positive sine. Now, if you get confused with differentiation and integration of sine and cos, just use this rule, SC, SC. I think you just put 2 negative at the bottom. Yeah, SC, SC. And how does that work? If you differentiate sine, you get cos. Differentiate cos, you get negative sine. And then I'll actually write a few more. Alright, so you get, where's the color? Okay. Actually, you write SC, SC, 2 negative in the middle. So if you differentiate sine, you get cos, and differentiate cos, you get negative sine. If you integrate cos, you get sine. Integrate sine, you get negative cos. Right? So if you go up, it's int. Go down, it's div. Okay, so you can use this rule to help you. So you won't get confused. So integrate sine is negative cos. Integrate cos is negative sine. Now differentiate cos is negative sine. Okay, good. Let's move on to the next bit. How do I integrate tan? That's not on the formula sheet. Write that as sine x over cos x. Write it as a fraction. And then what do we do? When it's a fraction, let's check whether the derivative of the bottom is the same as the top. So I'm going to differentiate cos x. And what's the derivative of cos x? It's negative sine, right? Remember using this thing? Differentiate cos, negative sine. So you get negative sine. So for you to use ln, you need to put a negative sign, because there's a negative sign, negative here, and then write negative ln of the denominator. Get the idea? So that's how we integrate tan. Alright, after we do this, we can integrate the next one. Just remember, if I differentiate sec, I get sec x tan x. That's not on the reference sheet, so you have to remember this. So that just becomes sec x plus c. Okay, good. After this, we continue. Cot x, you do the same as tan, just write cos over sine. And you can check that if you differentiate sine, you get cos. So you get ln. So integrating cos is a bit easier. There's no negative involved. Right, good. The last one, just use the complementary angle. So change cosec into sec of 90 minus x. And then the other one is tan 90 minus x. So you end up getting sec of 90 minus x with a negative in front. But sec of 90 minus x is cosec. So you get cosec x plus c. So the negative is there to produce that negative p. Oh. Right, so you can see more. Okay, good. Okay, hopefully you're all finished. Now, integral of sec x and cosec x is not part of the Frener course. However, we can still show it to you because you can still understand it. Let's try to do that, but it's not in this course. So what you do is this: you use that trick, write sec x as sec x over 1, and when you write sec x over 1, multiply top and bottom by this sec x plus tan x over sec x plus tan x. I'll just show it to you so that you see where that comes from. Okay, so if you expand the top, you get sec square x plus sec x tan x. And why do I make things complicated? For a reason. Okay. Alright, so we write it as a fraction, and whenever we write it as a fraction, it could be ln. Let's check whether ln works. If you differentiate the bottom, see if you get the top. So let's check. Check. So if I differentiate sec x plus tan x, you end up getting, what do you end up getting? You get, what's the derivative of sec? It's sec x tan x. What's the derivative of tan? Sec square x. It's the top, isn't it? So once the numerator is the derivative of the denominator, it becomes the ln of the denominator. For this reason, we don't put that in the extension 1 exam because it's too hard. But you can see where that comes from. All right, good. All right. Further examples. So in this course, in addition to other sine square x, cos square x, you need to be able to do this. And these ones, they don't provide the substitution. You need to know what to do. The following integrals where substitutions are not given, how do I do this? The rule is to let u equal to the trig function with the power. See the one with the power? You let u equal to cos x. And then you'll be able to reduce it to something easy to do. So what you do is this: let u equal to cos x, du dx is negative sine x, du equal to negative sine x dx, like that. And then you can write negative du equal to sine x dx. So that sine x dx you see at the end are now replaced by negative du, right? And the first before cos cube become 4u cubed because u is cos x, and it becomes a nice integral to do. So you end up getting integral negative 4u cubed du, which you can do easily. Okay, so what do? We just get u to the power of 4 minus plus c, and replace the u by cos x again. It's your answer. Right, so you need to know to do this. So the key things to note in this is to write things, let u equal to the trig function with the power. Okay? Alright, try the next one. Next one, both doesn't have power, so what do? It doesn't matter. You can let u equal to sine x, or you can let u equal to cos x. Doesn't matter, it gives you the same answer. It gives you a slightly different answer, but they're equivalent. So you do du equal to cos x dx. Differentiate sine is cos, and that becomes integral u. This thing becomes du. Like that. And then when you integrate u, you get half u squared plus c, and u is equal to sine. So you get half sine squared x plus c. Done. Right? Okay, good. Now, can anyone see a different way to do this other than this? You can let u equal to cos x, but can anyone see using another way? Doesn't use a substitution. You can avoid substitution altogether. Anyone? No? Well, you know that there's a formula, sine 2x equal to 2 cos x sine x, isn't it? Which is this thing. So that means when I integrate it, when I write sine x plus sine x cos x, that's equal to half sine 2x. So that means I could integrate, so I'm going to write method 2. Method 2. So I could do it like this. So I could do integrate sine x cos x is equal to integral half sine 2x, which is equal to negative 1 over 4 cos 2x plus c. And we know cos 2x is the same as sine square x. Remember the formula we just discussed today? They are actually the same. Same. Why are they the same? Because cos 2x equal to 1 minus 2 sine square x. Right? So they are the same. Right? Cos 2x is the same as sine square x. Right, good. So you can do it in both ways. And then try the HSC question. That's been asked before. Have a try. Alright, at the bottom. If you don't have your booklet, have a look. Alright, good. Have a try this example. So see there's a sine square x, just let u equal to sine x. And that will work. Make sure you change the limit as well. Change the limit. So you get when x equal to 0, u is 0. When x is pi over 4, u equal to 1 on root 2. And then you do it. Okay, have a try. And then you do du equal to cos x dx. Alright, let's try to do. So let's write it in a way so you can do it. So you can write that as 0 to pi on 4. Group the cos x with the dx together. So therefore the du is that du here. And that's going to become u squared And the limits also have to change to 1 on root 2 and 0. It becomes an easy integral to do. So we continue on with the calculation. So u squared is u cubed over 3. The answer will be exact form in terms of a third. So write that as 1/3 1 on root 2 cubed minus 0. How do you cube 1 on root 2? You just go 1 over 3 times 1 on root 2 times 1 on root 2 times 1 on root 2 minus 0 is not needed now. And then 1 on root 2 times 1 on root 2 is equal to half. Half. Okay, 1 on root 2. Hopefully you can see that. And then once you get half, 1/3 times half, you get 1 over 6 root 2 is your exact answer. I'll enlarge that so you can write it down. Alright, good. Have a think. And then we'll look at 2 HSC questions, then we're done. Okay, good. All done. Okay, let's move on. HSC question, part 1. There's 2 we're going to do. Let's do the first one. So this one look like this, but they have a clue in the first part. Expand this. That will help you to do the second part. Part 1. So all you have to do by expanding, so you have to show your expansion for 1 mark. So you do sine of, using your compound angle formula on page 21, sine 5x cos 4x plus cos 5x sine 4x plus sine 5x cos 4x minus cos 5x sine 4x. And you will see that the 2 terms get cancelled and you end up getting double sine 5x cos 4x. That's what you do in part 1. Okay, write it down. Oops, press the wrong button. Oh my. Okay, now how do I do the second part? Integral of sine 5x cos 4x. So what you do is, since the formula we just proven have an extra 2, I put an extra 2 but divide by 2 at the same time. So put a 2, put a half. And why do I put a 2? Because when you have a 2, that becomes exactly sine 5x plus 4x plus sine 5x minus 4x. I'm just using this formula above, this formula. So I'm just writing this thing in terms of this, which is what I got there. But this is not the answer, this is the integral. We have to integrate it. And the question is, how do I integrate? Before you integrate is to collect like terms. Where are the like terms? The 4x and the 5x, which is 9x plus sine x dx. Again, with a half in front. So these are like terms. And then you can just work out. So integral of sine is negative cos, so you get negative 1 on 9 cos 9x plus minus cos x plus c. And then you expand the half, you get negative 1 on 18 cos 9x minus 1 on half cos x plus c. Right. All done. So you can get this type of questions that doesn't involve the technique that we've learned before, but you just have to use what the question asks you to do. Use the compound angle formula, and then use it to help you to do part 2. So basically, you always turn it into a sum of sine and cos. So whenever you have a product there, you can't do it. So the rule is change the product into a sum. That will allow you to do the integral. And then we've got one more question to do. Okay, after we finish, let's go to the next page. All right, one more question. This one is a bit different. They ask you to differentiate, hence integrate. So let's do that. How do I differentiate this? What rule do we use? Not chain rule and product rule. We have to use the product rule. Let's use the product rule. Differentiate that. You get, that's your u, that's your v. So it's u dash v plus uv dash. U dash is 3 e to the power 3x times by v plus u v dash, which is negative sine x minus 3 cos x. So how do I simplify? You can either expand or factorize, take out a common factor out, which is sine e to the power 3x. So factorize. So e to the power 3x. So make sure you times the 3 by what's inside. So you end up getting 3 cos x minus 9 sine x. And then you get minus sine x minus 3 cos x. And then you will find things get cancelled. The 3 cos x gets cancelled. It ends up getting negative 10 sine x, which you can put the negative 10 in front, e to the power 3x sine x, like that. And then that will be useful for part 2. Okay, we're going to do part 2. So, yeah, just let you finish that first. Okay, so how do I do part 2? What we do is this. To do part 2, when you integrate e to the power 3x sine x, we can write that as e to the power 3x sine x, but put a negative 10 in front, because that has a negative 10, and put a 1 over negative 10, negative 1 over 10. And in this way, we can integrate it, so you get negative 1 over 10. The primitive of that is when we differentiate what we differentiated before, which is e to the power of 3x cos x minus 3 sine x plus c. Alright, like that. So you just have to put an extra negative 1 over negative 10 and put a negative 1 over 10 in front. The primitive can be found. Alright, good. So today you do exercise 10 or 11. Let me see what exercise. Today you do exercise 5.11. 5.11. Okay, done. Good.